Assalamualaikum dan salam sejahtera. So in previous tutorial, we covered the introduction to Laplace transform, which includes the properties of Laplace transform and how we can obtain the inverse of Laplace transform. In this tutorial, we will be discussing the application of Laplace transform and use it to solve for a specific response or parameter in a given circuit. For question 1, you need to find the response, in this case the I of t, for the given series RLC circuit. You are also given the value of L, R, and C as well as the initial condition. Firstly, since everything is in the time domain, we have to transform the equation into the S domain. So here we will use the Laplace time differentiation properties. Okay, this part right here is the transformation of the di squared t over dt squared. So we use the d squared f over dt squared, which is s squared f of s. So we have s squared. In our case, it is I of s minus s f of 0. In our case, it is minus si of 0 minus f prime of 0. In our case, this is di of 0 dt. And this part right here is the transformation of the r di over dt. And this one here is the I of t over s equals to 15. So this whole equation is the S domain representation of the equation given to us. Okay, now we group all the I of s together and bring the rest to the other side of the equation, and we solve for the I of s. Alright, so this is the first step where you transform everything into the S domain and solve for the I of S. So the second step is to actually perform the partial fraction expansion, but before that we have to find the root of your denominator. You need to find the poles of your system. Okay, once you have the pole of the system, you perform the partial fraction expansion and try to solve for the A, B, and C using any method that have been covered in the previous tutorial. You can use the residual method or the algebraic method, or you can actually combine the two methods together to solve for this A, B, and C. Okay, in this case, the A equals to 3, B 5.924, and C is negative 1.4235. Finally, we can find the inverse Laplace when we have solved for the A, B, and C by using the Laplace transform table, just as what you have done in the previous tutorial. Okay, now for question 2. You are given the circuit here and you need to solve for the value of I of t for t equals to 0. And you are also given the I of s, which is 60 U of t ampere. Again, the first step is to transform the circuit to the S domain and to include all the initial condition of the capacitor as well as the inductor. So we go back to the circuit. Because there is no switches in the circuit, at t equals to 0, the capacitor and the inductor is already at steady state. So the I of 0 is actually equals to 0 and the V of 0 will be equals to 20. Okay, so these two are the initial condition that we have determined, and it has to be included in the circuit. The way we can include this initial condition is by referring to this figure. So for the capacitor, the initial condition is to include the voltage source in series with the capacitor, and the value of the voltage source is the V of 0 over S. And for the inductor, also the same, we include the voltage source in series with the inductor, but the value is Li of 0. Okay, but because I of 0 is equals to 0, see we don't have initial condition for the current, so we can omit this altogether. So what we are left with is just the initial condition for the capacitor. So the overall circuit that have been transformed to S domain is as shown here. Alright, next step is to solve for the circuit using any circuit analysis method. In this case here, we use mesh analysis. So we go around the mesh. First, we have 1 times I is the current flowing through the mesh, minus the 60 over S current source. And then 3 times I plus S times I plus the 20 over S minus 20 over S plus 25 over S times I. Then we group all the I together and we solve for the I. So just like in the previous question, next step is to perform the partial fraction expansion to solve for the A and B. Again, you can use any method of your choice to solve for this A and B. And once you solve for the A and B, you can find the inverse Laplace for the I. And this I of t can be further simplified using the trigonometry identity. And the final answer is 13.093 e to the minus 2t sine 4.583t. Question 3 wants you to solve for the I0 of t in the given circuit. So you need to solve for this one. Again, we take the similar steps as the previous questions. So first we have to transform the circuit into the S domain and include all the initial condition in the circuit. In this case, all the initial conditions are 0 because there are no sources for t less than 0. And the final S domain circuit is as shown here. Okay, next we have to solve the circuit using any circuit analysis that is suitable. In this case, it's very simple. I just apply the Ohm's law. So V equals to I, and the total impedance of the circuit. And next, since we are interested in I of 0 of t, we need to first find the I of 0 of S. So it's just voltage over the impedance. So it's V over 2 over S. So we bring that S to the numerator, and we end up with this equation for I of 0 of S. Okay, next, similar to previous questions, we have to perform the partial fraction expansion. And we have to solve for this value of A, B, and C. And finally, once you solve for the A, B, and C using the method of your choice, you can transform the S domain back into the time domain by using the inverse Laplace table. So this is the final answer once you use the table to find the inverse Laplace. And again, you can further simplify this I of t by using trigonometry identity, and your final answer will be this one as shown here. This is our last question, question 4, and for this question, you need to find the complete response of the circuit given V of 0 equals to 100 when the switch is closed. So basically, the initial condition is already given here. Okay, so what does complete response mean? Complete response basically is saying that you need to give the response for t bigger than 0 as well as t less than 0. So that is the complete response. Unless the t less than 0 is 0, then you can omit it altogether. But if there are value for t less than 0, then you have to include it as part of your response. Again, Similar to previous question, you have to transform your circuit into the S domain and include the initial condition. In this case, the initial condition has already been given, which is 100. So we place it in series with the capacitor. And next, we solve for the circuit. Here we can apply KVL around the loop. So we first start with the voltage source plus the resistor, inductor and capacitor times the I plus the initial condition 100 over S. We group all the I together and solve for the I. Okay, but we want the complete response V. Okay, so let's go back to the original circuit. So we want the complete response of the V. So actually I already labeled it here. The complete response includes the voltage across the capacitor as well as the initial condition. Okay, so V equals to, this is the capacitor times the whatever I that we found up here plus the initial condition. So this is the complete response in the S domain. Next, we perform the partial fraction to solve for the A, B, C, D, and E. And for this specific circuit, the parameters are shown here. And finally, we find the inverse Laplace for this circuit. So this is our complete response of the given circuit. So just to conclude everything from this chapter, basically you are trying to apply the Laplace transform to solve for whether you want I of t or v of t for a given circuit. The steps are all similar, just as you may have noticed in these questions. First, you have to calculate the initial condition and transform the circuit or the equation into the S domain and include all the initial condition in the S domain circuit or equation. Second, you solve the equation or solve the circuit by using any circuit analysis method. If you recall from this tutorial, we did some KVL and then we also do mesh analysis. So it depends on the type of question that is given to you. And once you solve for the circuit, you solve for the parameter of interest, whether you want I or you want V. Okay, so from there, you perform the partial fraction, expansion, and you apply any method of your choice to solve for the respective constants. And finally, you find the inverse Laplace, just as you did in the previous tutorial. Sometimes the inverse Laplace can be further reduced. As you can see, you can use some trig identity. However, it's not as crucial as long as you get to the final inverse Laplace. As long as you get the final inverse Laplace, even though it is not as simplified, that is actually the most important thing for the lecturers. That is what they are looking for in the test. Okay, so that's it for the last tutorial of this semester. Thank you very much.